In the past 30 years, the interest in language production has given rise to a number of psycholinguistic models that have tried to account for how language goes from mind to mouth. More specifically, psycholinguistic models of language production have tried to provide an explanation for the efficiency and accuracy of the system. Hence, they have tried to discover how an average speaker can produce language at a rate of 2 to 3 words per second, that is 120 to 200 words per minute, and with a very low rate of errors of approximately 1 error every 1000 words. One of the most prominent models that many researchers use as the basis for their investigations in the field was authored by a Holland professor Leveld. His speech production system consists of a number of autonomous components, which are responsible for different aspects of speech production. These components include the conceptualizer, a component that is responsible for generating and monitoring messages, the formulator, in charge of giving grammatical and phonological shape to messages and which feeds on the lexicon, the articulator, which specializes in the motor execution of the message, an addition of acoustic phonetic processor, which transforms the acoustic signal into phonetic representations, and the speech comprehension system, which permits the parsing or processing of both self-generated as well as other-generated messages. The first component in Leveld's production system is the conceptualizer. This component is responsible for generating the communicative intention and for encoding it into some kind of coherent conceptual plan. In addition, the conceptualizer monitors what's about to be said, as well as what has been said and how. In order to generate a message, declarative knowledge is assessed. Declarative knowledge includes encyclopedic knowledge about the person's general experience of the world, knowledge about the situation, as well as information about the discourse record. That's what has already been said. Leveld distinguishes two stages in message planning: macro planning and micro planning. Macro planning consists of retrieving information to express the sub-goals into which the overall communicative goal has been elaborated. The product of macro and micro planning is what Leveld refers to as pre-verbal plan. That's an organized conceptual structure which is not yet linguistic and which constitutes the specific input that the next processing component, the formulator, will work on. It's important to briefly highlight at this point the fact that conceptualizing the message requires attentional control. That means that different types of information needed to express the intention have to be attended to in order for them to be retrieving from long-term memory and instantiated into working memory, a task which is supposed to take up memory resources. In the next component in the production system, the formulator, the propositionally organized preverbal plan, activates the items in the lexicon that best correspond to the different chunks of the intended message that will in turn be responsible for transforming it into a linguistic structure. In Leveld's model, grammatical and phonological encoding are lexically driven. For grammatical encoding to take place, both lexical access procedures and syntactic procedures are applied. In the lexicon, each lexical item is specified for semantic and syntactic information. We call them lemmas, and morphological and phonological information, lexemes. A chunk in the preverbal plan activates a number of lemmas in the lexicon. The lemmas, which receive the highest activation because their semantic specifications match the concepts in the preverbal plan, will be selected. When a lemma is retrieved, because it matches parts of the preverbal message. Its syntactic properties become available and they trigger syntactic building procedures. The procedural knowledge stored in the grammatical encoder, which is activated by the syntactic information in lemmas, works to build the syntactic structure of the sentence, which Level refers to as surface structure. The lexical pointer specified in the lemma then triggers the phonological encoding process, which results in the selection of specific morphological and phonological forms. The output of the formulator is a phonetic plan or articulatory plan, which is ready for articulation. Leveled refers to this articulatory plan as internal speech, as opposed to already articulated overt speech. The articulator is the next component in the speech production system. As the phonetic plan is being generated, its bits are temporarily stored in an articulatory buffer. This buffered information will trigger the unpacking of motor commands, which will finally cause articulation of the message. It is this buffered speech which speakers subjectively experience as internal speech. The outcome of articulation is overt speech. While it can be argued that most aspects of second language production can be explained by models of first language production, there are some particularities of second language speech, especially that of unbalanced bilinguals or second language learners, that require a different kind of explanation. Palissy suggests that there are three major differences between the two types of production, which have to do with the size of the lexicon and the specification of its items, the degree of automaticity with which processing proceeds, and the presence of traces of the first language in the second language production. Firstly, second language knowledge is not as complete as first language knowledge. Second language speakers may find difficulties in expressing some concepts because, for example, they cannot find the right words to express them. Furthermore, some lexical items in the lexicon are not fully specified for their semantic, syntactic, morphological, and phonological information, which often leads to errors. Also, the relationships between different lexical items may not be fully specified yet. When a second language speaker has trouble retrieving a lexical item, a number of compensatory strategies are applied. Additionally, grammar knowledge of the second language is underdeveloped, which may lead second language speakers to avoid them. Secondly, certain aspects of processing in the second language production system lack automaticity. While message formulation is thought to be quite automatic in the case of the first language, lexical retrieval and encoding may require serial processing for second language speakers. As Palissy suggests, this mainly happens at the morphophonological and articulatory levels. In general, second language production tends to be more hesitant and the rate of speech slower, and the degree of automaticity may vary depending on the second language speaker's proficiency. Palissy also notes that second language speakers produce twice as many slips of the tongue in the second language than in the first language. In the third place, second language production carries traces of the first language. First language use during second language production can be the result of intentional code switching or the consequence of unintentional performance switches. In the case of intentional code switching, the possible reasons behind it are multiple. One particular lexical item may be missing. There may be greater availability of first language words. The speaker may wish to emphasize his or her identity, or change of subjects is intended. The speaker wants to specify a particular addressee, to express an emotion, or simply to mark asides from the ongoing discourse. Unintentional switchers are commonly referred to as transfer or cross-linguistic interference. Furthermore, the level of proficiency may affect both intentional and unintentional code switching. Low proficiency learners may willingly resort to first language words when they are communicating in the second language. Low-level learners display more instances of involuntary transfer when speaking the second language than high proficiency learners.